Welcome to my final video for the SAT Maths section. In this video, we're looking at the coolest topics within the SAT Maths, trigonometry and complex numbers. They are my absolute favorites because, yeah, they're pretty cool, to be honest. The rest of the SAT Maths section is pretty boring, and even this, rather, they cover really elementary stuff, which is actually pretty great because it means it's pretty easy to score. And and I'm pretty sure the trigonometry that you cover in the SAT is the all of you already know it, is what I'm trying to say. And complex numbers, if your school or curriculum has covered it, you also probably already know everything that's covered. If not, it is still pretty easy, so you'll catch on, don't worry. Otherwise, just leave a question in the comments, we'll get back to you. I'll get back to you. And in the habit of using we, that's pretty weird. But right, and yeah, so let's start, right? So in trigonometry, all you need to know is the sine, cosine and tangent ratios. So when I mean opposite, I mean the angle opposite the side opposite the angle. Adjacent is the side that is not the hypotenuse or the opposite, so it's the third side. The reason I'm clarifying this is because some people refer to these as perpendicular base and they've got other names for it. So just in case that's you, that's what I mean by opposite and adjacent. And if you do have difficulty remembering that sine is opposite by adjacent and so on, this is mnemonic I learned back in the 6th grade. That's never failed me, so let's go over it. Some old horses, sine is equal to opposite by hypotenuse. Can always hear, cosine is equal to adjacent by hypotenuse. Their owner's approach, tangent is equal to opposite by adjacent. Some old horses can always hear, their owner's approach. There are many mnemonics, but I personally, this is the first one I came across and it's been with me since. Now this is something that the SAT does not explicitly ask for you to know, but I have seen some practice questions test it. So sine 180 minus x is equal to sine x, which means sine, if x is 30 for example, sine 150 and sine 30 are equal. Or if x was 81, sine 109 and sine 81 are equal. Similarly, cos 360 minus x and cos x are equal, and tan 180 plus x and tan x are equal. To convert something from radians to degrees, you multiply it with 180 and divide it by pi. For degrees to radians, multiply by pi, divide by 180. Let's jump to a question straight away. So it's always good in a trigonometry question to draw a diagram. In this question, we have a flagpole that's 10 meters tall. One person 2 meters tall is standing 21 meters away from it. So to find that angle of elevation, we need to know, this is the right angle triangle that comes in question. So we need to know that height and that length. That is just 21 meters because it's also, his head is 21 meters apart from the flagpole, just like his feet. And that is 10 minus 2 basically, so that's 8. That gives us an updated triangle. Now we're dealing with the opposite and adjacent sides over here. So with the tangent is the ratio we're using. Tan x is equal to 8 by 21. Therefore we can use the arctan, tan inverse, whatever you call it, to get 0.364 radians if your calculator is in radians mode, or 20.9 degrees if it's in degree mode. Once again, to convert from radians to degrees, multiply by 180 divided by pi. To convert from degrees to radians, multiply by pi divided by 180. Now this is another kind of question that's fairly common. So tan x is 3, find sine x cos x. So there are two ways to do it. The first is to find arctan x in your calculator. That's approximately 1.25 radians, and then you just do sine 1.25 into cos 1.25 and you'll get the answer. Now I have rounded things off over here, so I've gotten a slightly rather approximate answer and not the exact answer, but you will be required to yield the exact answer, and that is no issue really, because when you type in arctan of 3 on your calculator or tan inverse of 3 on your calculator, you'll get a number with a long number of decimal places, and that will be stored under answer. So you just need to do sine answer into cos answer and you'll get the exact answer. Now if you want to do it manually, it's also possible. Tan is equal to opposite by adjacent. So what we can do is we can draw a right angle triangle, label one of the angles x, and do opposite by adjacent. 3 can be written as 3 divided by 1. So we can say opposite is 3 and adjacent is 1. Using that, we can calculate the hypotenuse, which is root of 10, because 3 square plus 1 square is 10, and the root of that is root 10. So from there we can get sine x, opposite by adjacent, 3 by root 10, and cos x, which is 1 by root 10, because adjacent by hypotenuse. And we multiply these together, that becomes 3 by 10, which is 0.3, and that is the exact and correct answer. And now that we've done that, let's go to complex numbers. This might be new. So any complex number is written in the form a plus bi. Now a is the real part, so it is 1, 2, 3, 4, 5, and bi is the imaginary part because it has I. B is a real number over here. I is nothing but the root of -1. And if you want to visualize it, as in how these numbers work, there is something pretty similar to coordinate planes, the Argand diagram. If you want to see how how you can plot these numbers over there, and if that helps you understand these better, do check out Argand diagrams and plotting complex numbers on them. And also, just while we're at it, something pretty interesting, if you wanna look at numbers in higher dimensions, is something called quaternions. I think Numberphile has a video about it, so I do recommend you check that out too if complex numbers is something that interests you. And there is plenty of material to learn from honestly. There's de Moivre's theorem and lots of things, but as for the SAT, you do not need to know any of that. Anyway, so in complex numbers, adding and subtracting two complex numbers is pretty similar to real number, or to adding or subtracting in algebra. Just before I elaborate on what I mean, I want you to recognize that one thing, that 5 and any real number, or 10 or 11 or 2 or -7, they're all complex numbers where the imaginary part is 0, because you can write 10 as 10 plus 0i. So we just don't write the 0i because it's 0, and therefore any real number is a complex number. Similarly, the number I itself is actually in this form. It is just 0 plus 1i, and because that's 0, we don't write it, and the 1 is implied, so we don't write it as well. So all the numbers that you have dealt with are actually complex numbers in a way. Anyway, back to adding and subtracting. So what I meant when it is very similar to algebra was that you add the real part separately, so 10 plus 14, 24, and you add the imaginary part separately, so 3 minus 2i, that's plus I. Similarly, if in subtraction, real parts 2 minus 3 minus 1, and imaginary parts minus 8i minus of negative 6i, that is minus 8 plus 6i, which is minus 2i, and it's pretty simple. I raised to the power 1 is I. Now we know that the root of -1 is I, so I squared is minus 1. I cubed is I squared into I1, which is minus I. I to the power raised to the power 4 is I squared the whole squared, so that is minus 1 the whole squared, that is 1. For any other positive whole number in the exponent n, divided by 4 and look at the remainder. If the remainder is 1, the answer is I. So I raised to the power 5, 5 divided by 4, remainder is 1, so it is I. If the remainder is 2, let's say for the number 6, I raised to the power 6, 6 divided by 4 has the remainder 2, and therefore it is minus, I raised to the power 6 is equal to minus 1. Similarly, if the remainder is 3, I raised to the power 7, for instance, when it is minus I. And finally, if the exponent is divisible by 4, so let's say something like 500, I raised to the power 500, if 500 is divisible by 4, the answer therefore is 1. And it's pretty simple to realize why this is the case. Just if you think about it, if you do not, leave a comment and I will tell you why. A square plus b square is equal to a plus bi into a minus bi. Now that's our identity. Just like we had a square minus b square is equal to a plus b into a minus b. A square plus b square is equal to a plus bi into a minus bi. And with that, we'll go into multiplying and dividing complex numbers. Multiplying is similar to how we do it in algebra. So we use the FOIL method. So for proving this identity, for instance, we can multiply the first terms first, a square, then the outer ones minus abi, inner ones plus abi, last ones so that is minus b square into I square is -1, so that is minus b square into -1, which is nothing but plus b square. The a square is also there, these two cancel out, so we have proved the identity. We can use the FOIL method for any set of complex numbers. So 2 into 8, 16, outer minus 6i, inner 56i, last plus 21, then we just add the real parts together, 37, and the imaginary parts together, plus 50i, and that is our answer. Now dividing, it's a slightly different process, so for that you need to know something called conjugates. The conjugate of any imaginary number, a plus bi, is a minus bi, as in the sign of the imaginary part just changes. So 3 plus 4i becomes 3 minus 4i, minus 2 plus 7i becomes minus 2 minus 7i, 3 minus 4i becomes 3 plus 4i. So just the sign of the imaginary part changes, right? That's the conjugate. Now when you have to divide something, it's pretty much how like rationalizing, if you have done that with surds before. So if I had to divide 7 plus 8i by 3 plus 4i, I'd first write it as a fraction with 7 plus 8i on the numerator and 3 plus 4i in the denominator, and then I would multiply both the numerator and denominator by the denominator's conjugate. So I'd multiply both the numerator by 3 minus 4i and the denominator by 3 minus 4i. Once we're done doing that, you must notice that the denominator will always be using the a plus bi and a minus bi identity. So this is so that is equal to a square plus b square, so 3 square plus 4 square, which is 25. Similarly, we can multiply the numerators by the FOIL method. 7 into 3, 21, plus 8i into minus 4i, which is plus 32, so 21 plus 32, 53. Then 24i minus 28i minus 4i. We can't leave it like this though, we must separate the real and imaginary parts, and leave it in the way we write complex numbers. So the real part is 53 by 25. The imaginary part is minus 4 by 25i, and therefore that is the answer, and that is how you divide complex numbers. Now this is a sample question, so once again we just need to divide by 4 and find the remainder. What we are just doing is the mod function, if you've heard of it. It's the percentage, it's a percentage sign symbol function in almost all languages, and it's also in basic number theory, the MOD thing. So what that does is basically it yields the remainder of two numbers you put. So if I say 5 mod 4, it will give me the remainder, that's 1. So what we're doing each time is actually we're doing 38 mod 4 and mod 4 and seeing what it yields. But if that confuses you, just think of it as finding the remainder when you divide by 4. 38 by 4 is 9 remainder 2, so we write the remainder down. 73 by 4 gives a remainder of 1, 103 by 4 gives a remainder of 3, 120 gives a remainder of 0. Now if the remainder is 2, we can that means I raised to 38 is equal to I squared, remainder is 1, so I raised to 73 is equal to I raised to the power 1, I raised to 103 is equal to I raised to the power 3, and similarly I raised to 120 is equal to I raised to the power 4 or I raised to the power 0, right? Now I raised to the power 2 is minus 1, I just is I cubed is minus I, and I raised to the power 4 is 1. Adding all of these together, the real parts, we get 0 plus 0, so it's 0. Another question, you might also get questions like this. So ai at raised to the power m is equal to b into I raised to the power n. So what are these? Which of these statements need to be true? Provided m is greater than n. Greater than or equal to n, sorry. And so the first thing is a and b have to be equal, because even if we mention that the even if we imagine this and this is equal, they so both of them, let's say, result in 1 and 1. It cannot be equal unless a and b is also equal. So that's almost a given, that has to be, that's given, it has to be equal. M minus n is a multiple of 4. Now let's imagine that a and b are equal, so because they have to be. Now if m and n have the difference between m minus n is a multiple of 4, that means the remainder that m divided by 4 and n divided by 4 will yield is going to be equal. So for example, 9 divided by 4 has a remainder of 1, 13 divided by 4 has a remainder of 1. Similarly, 17 divided by 4 has a remainder of 1, and the difference is 4 and 8 respectively. So we see that every time the mod function or the remainder is equal, if the difference between m and n is multiple of 4, therefore im in that case would be equal to in if the m minus n had a difference that was a multiple of 4, and therefore that has to be true. Third, m is equal to n. This does not need to be true because as we saw that I raised to the power 9 is equal to I raised to the power 13. 9 and 13 are not equal. This can be true, so m and n can be equal, and even then that would work, but it does not need to be, and therefore the answer is 1 and 2 or option B. With that, guys, thank you so much for going through my videos. I hope that actually helped. Good luck for your SAT, guys. I mean, you got this, don't worry too much. You always have a second try, and I'm pretty sure that if you know how to do it, that score is yours, right? Like, all you need to do is just learn the grammar rules, for instance, learn about how to approach reading questions, and just learn everything that comes in your math section, and pretty much the score is yours, right, with practice. So don't really worry too much, just practice. You will do great, don't worry, and do let me know actually if you do well, because I'd be really happy that it helped, and also do let me know if it actually helped. With that, guys, thank you so much. Have a great day.